Good morning to one and all. In this class, we are going to discuss about three problems related to economics of power generation. First one is daily demands of three consumers are given below. First one is consumer one, consumer two, consumer three. For a consumer one, during a day, different loads they are connected between 12 midnight to 8 a.m. There is no load on consumer one is having no load, and consumer one is having load of 600 watts between 8 a.m. and 2 p.m. and 200 watts between 2 p.m. and 4 p.m. 800 watts between 4 p.m. and 10 p.m. There is no load after 10 p.m. to midnight. Same way, consumer 2 is having 200 watts, no load, 1000 watts, no load, 200 watts. And consumer 3 is having no load, 200 watts, 1200 watts, no load, and 200 watts. Plot the load curve and find. We need to draw a plot curve for load curve for these things and find maximum demand of individual consumers. Maximum demand of individual consumer means, say for example, for consumer 1, it is having maximum load of 800 watts between 4 p.m. to 10 p.m. Therefore, for a consumer 1 load factor is their maximum demand is 800 watts. In the same lines, consumer 2 is having maximum demand between 2 to 4 p.m. And its value is 1000 watts. For a consumer 3, it is having maximum demand of 1200 watts between 2 p.m. to 4 p.m. This is the first question. And second question is load factor of individual consumers. Load factor is equal to number of units consumed divided by maximum demand into time. Time is 8760. If it is given as this one day, it is equal to 24 hours. And maximum demand of consumer 1 is 800. And number of units generated is equal to 600 into there is no load between 12 and 8. So you leave it. 600 watts is there between 8 a.m. and 2 p.m. That is 6 hours. 8, 9, 10, 11, 12, 1, 2. Therefore, 600 into 6 because 1 unit means kilo. Number of units generated is equal to 1 kilowatt hour means 1 kilowatt per hour. So 600 watts into 6 hours plus 200 watts into 2 hours plus 800 watts into 8 with 4 p.m. to 10 p.m. means 6 hours and there is no remaining time. Therefore, load factor is equal to 600 into 6, 200 into 2, 800 into 6 divided by 800 into 24. That gives you 45.8 load factor of consumer 1. And load factor of consumer 2 is in the same lines 200 into 8 is load for 8 hours plus 1000 into 2. This is 1000 for 2 hours plus 200 into 2 hours midnight 10 p.m. to 12 p.m. means 2 hours divided by maximum demand on maximum demand of consumer 3 is 1200. That is equal to 1224. That gives you 13.8. And for these three loads, we need to draw a load curve. Load curve is drawn between these all loads. And third question is diversity factor. Diversity factor is sum of individual maximum demands divided by maximum demand of power station. From the load curve we can find this is the load curve for power plant. So power plant is having maximum demand of 2400 watts. Therefore, maximum demand of power station is 2400 watts. And sum of individual maximum demands means sum of first one consumer 1 maximum demand is 800. Second, consumer 2 is 1000 and consumer 3 is 1200 divided by 2400 gives you diversity factor of a power plant. And third one is load factor of the station. Load factor of the station is equal to average demand or number of units generated divided by maximum demand into time. Or otherwise, area under the curve gives you load factor is maximum demand means maximum demand on power station is 2400. The average demand is 2000. All this area divided by 24 hours gives you 24 hours gives you maximum load factor. Here load factor is equal to total energy consumed per day divided by simultaneous maximum demand 24 into 100. In any manner we can find 2 or 3 ways we can do the problem. And next one is a power plant has the following load cycle: 6 to 8 20 megawatts, 8 to 12 40 megawatts, 12 to 16 60 megawatts, 16 to 20 20 megawatts, 20 to 24 50 megawatts, 24 to 6 means morning 6 it is 20 hours 20 megawatts. Plot the load curve and load duration curve and calculate energy generated per day. Is the load curve. Load curve is drawn between load and time of day. Here from 0 to 8 hours, 0 to 8 hours, the load is 20 megawatts. Here 0 to 8 hours, load is 20 megawatts. And 8 to 12, the load is this 0, it seems. We have only given 6, I think, or 0 is taken as a reference then. Uh, 8 to 12, 8 to 12, it is 40 megawatts. In the same way, 12 to 16, 60 megawatts. 16 to 20, 20 megawatts. 20 to 24, 50 megawatts. And 24 to 6, it is 20 megawatts. Also, same values given for these values. So, we have drawn the load curve. And from here, maximum demand we can find, as well as here the question is load duration curve also need to be drawn. Load duration curve is first we have to draw maximum demand. Maximum demand on power station 60 megawatts for how many hours? Here 12 to 16 means 6 hours. 12 to 16 means 4 hours. 0 to 4 hours, the maximum demand is 60. So next level is, next highest peak is this one. This is drawn between uh, 0 to 20 to 24 means 4 hours. So 4 to 8, the value is 50. The same way, in the descending order, we need to draw a load duration curve, and area under the curve gives you total number of units generated in a day. For this one, 0 to 8 hours, the load is 20. So 8 into 20 plus 4 into 8 to 12 means 4 into 40. The same way, we need to find all the areas of all these areas. And finally, if you add all these things, we'll get area under the curve. That is number of units generated. In the same way, if I find area of load duration curve, the values will be the same. You see, units generated per day, if I calculate for load curve, it is 840 into 10 power 3 units. In the same way, for load duration curve, if I find area, that is 840 into 10 power 3 kilowatt hours, same thing, 840 into 10 power 3 units. The annual load duration curve of certain power station can be considered as a straight line from 20 megawatts to 4 megawatts. To meet this load, 3 turbine generator units, 2 rated at 10 megawatts each and 1 rated at 5 megawatts. So totally 3 units are there. 2 units are 10 megawatts means 10 plus 10, 20 plus 5, 15 megawatts, 25 megawatts. Determine installed capacity. Installed capacity means what are the generators installed in the power plant. So total generator units installed are 25 megawatts. And second question is plant factor and units generated per year. Units generated per year is, you can calculate units generated per year is equal to area under the load duration curve. Load duration curve is drawn between, here it is straight line from 20 megawatts to 4 megawatts. Out of 1 year, 0 to 8760, it is load is from 20,000 to 4,000 kilowatts. It is a straight line as given. So this is the load curve, and area under the load curve means of 1 by 2 into, we have to average these two, 400, 4,000 plus 20,000 divided by 2 into 8760. This average into 8760. Will give you area under the load curve, load duration curve. That itself and number of units generated per year. And next one is plant capacity factor. Plant capacity factor is equal to number of units generated per year divided by plant capacity into 8760 hours. Here number of units generated per year is 105.12 into 10 power 6 divided by plant capacity means installed capacity itself and plant capacity, that is equal to 25 megawatts. Therefore, divided by 25 megawatts into 8760 will give you plant capacity factor. And also next one is load factor. Load factor is equal to maximum demand divided average demand divided by maximum demand. Average demand or area under the load curve into load curve divided by maximum demand into time. You can write in that way also. Maximum demand is 20,000 20 megawatts into time is 8760 and number of units generated are this one. So definitely you can find load factor. And utilization factor is maximum demand divided by plant capacity. Maximum demand is 20,000 divided by plant capacity is 25,000. That gives you 0.8 utilization factor, or sometimes you can call it as an 80% of utilization factor. Thank you very much.